Okay, you're welcome to this second segment of the calculator class. Okay, so this question here says we should integrate exponential 3x. And of course, to give a brief illustration there on integration, when you integrate integral of exponential ax dx is going to be 1 over a, then exponential ax, then plus c. Another way you can write it as exponential ax all over a, then plus c. So in the case of exponential 3x, integral of exponential 3x dx, it is going to be exponential 3x all over 3 plus c. So that's the answer to the question. Okay? So let's go back to our question. The next question says, okay, so the answer to this is B. B is the answer. Now the next question says, let me zoom this. We're asked to differentiate x over x plus 1, and we are given different options. Okay, the best thing to do here for me, I would say, is using calculator. So let's go to our calculator. We have integral of x over x plus 1, and let's see. So, I mean, differentiating x over x plus 1. So, let's see. So, we have shift this. You have your differentiation. Then it is x over x plus 1, x alpha x, and all over x plus 1, alpha x plus 1. Okay. Then we shift our cursor, x equal to, we can choose any value. Let me choose 2. So, x equal to 2. So we've got 0.111111. So any of the options that gives us 0.11111 is the answer. Okay, so we are going to try that. I have the options here. So we are going to try each of the options and see which one will give us 0.1111 when x is equal to 2. So let's try the first option. The first option is 1 over, sorry. Okay, so we have 1 over x squared plus 4x plus 4. We have alpha x squared plus 4 alpha x plus 4. Then calc. Okay, then 2 equal to, this is not the answer, it's not giving us the same thing. So the next one, with your calculator, you can adjust, but with this, my calculator, I'll have to do it one by one. But with your own calculator, you can adjust. I wish I can. Okay, I can adjust. Oh, that's good. So x squared plus 2x plus 1 is the next one. So we have 2x, x squared plus 2x plus 1. 1 over, that's the b. So this is it. Then calc. Let's see, 2 equal to 0.11. That's the answer. It gives us the same thing. So we go back to our question. Which of the option is x squared 1 over x squared plus 2x plus 1? So go back to our option. We can see that the answer is B. With our calculator, we get the answer very fast. Okay. So we'll move to the next question. The next question here says we should differentiate n6 all over n raised to power 8. For me, this is simple. It's something we can just do. So let us do it together. N6 over N8. So we have to differentiate N6 over N8. Now, first of all, N6 over N8 is the same thing as saying, if we divide, it's the same thing as saying 1 over N squared. That means 6 here, 1, 6 here, 2. That's all. You apply the law of indices. Or we can just say N raised to power 6 minus 8, which is N raised to power minus 2. This is good. So if I'm differentiating N raised to power minus 2, what am I going to get? Minus 2 comes down. Then N raised to power minus 2 minus 1. Okay, so that will now be minus 2. Then N raised to power minus 2 minus 1 is minus 3. So that means the final answer now will be minus 2 all over N cubed will be the answer. You can also use calculator to do that using the method I used in the previous case. So let's see. So minus 2 all over n cubed. So the answer is D. This particular person got that wrongly. So the answer is D. But you can use your calculator, you know. Maybe we can try that quickly for those of you that, think without calculator, you can't do it. So let's say alpha x raised to power 6. Sorry, this is raised to power 6. Okay, now all over alpha x raised to the power of 8. Oh, sorry, I'm supposed to have a differential sign. Sorry, differentiating. So shift this. Okay, so alpha x raised to the power 6. Now divided by, we have alpha x raised to the power of 8. And choose any number of your choice. Let's say we choose 2. So 2 equal to, so minus 0.25. So which of the options will give us minus 0.25? We remember minus 2 over n cubed. So let's write that minus 2 over n cubed. We have minus, we have 2 all over x cubed. So alpha x cubed. Let's see if it's going to give us the same thing. Alpha x cubed. So calc. So let's try 2 now. Again, 2 equal to, did you see that? It's giving us the same answer. So that's how we know that that is the answer. Okay. So that's for those that prefer to use calculator. Now the next one here, this is range. We are asked to find the range of f of x equal to ln x squared plus minus 4. Well, one of the best ways to go about this, I don't need to think. For me, I know that the answer is set of all real numbers. The reason is because to find range, we need to find the inverse of that function. And the inverse of that function, inverse of a ln function is exponential function. And I know that exponential function is always defined. So let's do that together, Let's do that together. Let's say we have, y. Let y be equal to ln x squared minus 4. Okay, to take away ln, it becomes exponential. Y is equal to x squared minus 4. So that means x squared is equal to exponential y plus 4 because of the 4. Then x is equal to square root of exponential y plus 4. Now, even though this is a square root function, but anytime a square root function has something like this, has a function like a raised to power x plus b, or has something like this, x squared plus a, the domain or range is going to be set of all real numbers. So the answer is R, set of all real numbers. Or you say from negative infinity to positive infinity. Okay, so let's go to the next question. So the answer here is E, the last option. Now the next one, we are asked to, given y equal to x raised to power 4, square root of x raised to power 4x, find the derivative of y with respect to x. It's easy. The answer to this question from my findings is E, and I'm going to confirm that using solving and also using calculator. So let's do that quickly. If we have to solve the square root of x raised to power 4x, so let's see x raised to power 4x quickly. Okay, so we have, trying to be sure my other phone is in line, or the other. Yeah, so x raised to power 4x. We start by saying let y be equal to x raised to power 4x. Okay, square root of x raised to power 4x, sorry. Now, first of all, square root of x raised to power 4x is the same thing as x raised to power 2x. And that's because the root there means divide the power by 2. Square root means divide power by 2. Okay, so the next thing, I'll take the natural log of both sides. That means ln y is equal to ln x raised to power 2x in this case. Okay, so that means ln y now is equal to, according to law of logarithm, this can be 2x ln x. So from here I can differentiate implicitly. Now differentiating implicitly means that differentiate ln y should give us 1 over y dy dx. Okay, equal to differentiate 2x ln x is product rule. That means 2x, we have 2x, differentiate ln x, then plus ln x, then differentiate 2x. So that is now going to be 2x times differentiating ln x here means 1 over x. Okay, and then plus ln x, differentiating 2x is 2. So I have 2 ln x. So this is going to give me x here will cancel x. So it's going to give me 2 plus 2 ln x. Okay. So if in that case, sorry, let me rub off this part. In that case, if 1 over y dy dx equal to that, we can now have something like this. Okay. We have 1 over y dy dx is equal to 2 plus 2 ln x. Okay. So that means dy dx is equal to y into 2 plus 2 ln x. And what is y? Y is x raised to power 2x into 2 plus 2 ln x. Okay? So with this, we can come up with a formula. Yeah, so that's the answer. That's the answer. Now, but we can come up with a formula that if y is x raised to power ax, please note this, then dy dx, x raised to power ax, please notice what it looks like. Dy dx now will be x raised to power ax into a plus a ln x. So use this as a general rule because we are still going to see a question like this. A plus a ln x. So let's go back to our question, which is so the answer to this question is E. X raised to power 2 plus 2 into 2 plus 2 log x to base E. Log x to base E is the same thing as ln x. Okay, so another thing I can say here is that we can use calculator. So maybe let's do that quickly. Let me do that quickly for us. Remember you have derivative, shift derivative of square root of x, that's alpha x raised to the power of 4x. So 4 then alpha x, something like this. So let's make our x to be equal to 2. Let's see the answer we get to equal to. So we got 58.14. So let's try the other guy, which is x raised to power 2x. So that means alpha x raised to power 2x to then alpha x into 2 plus 2 ln x. That's alpha x. So close the bracket, close the bracket. You see that? Then press calc. Then 2 equal to, did you see that we got exactly the same answer? So that means that confirms that that is the answer. So for those of you that prefer using the calculator method. Now we go to the next question. The next question says we should find the singularities of a function. I think we've done something like this before. The singularities of a function. To find singularity of a function, solve the denominator. Equate the denominator to 0, then solve it. So that is going to give us x squared minus 7x plus 12. The answer will be E. That means 3 and 4. But if you must use your calculator, x squared minus 7x, I think that's x squared minus 7x plus 4. You go to your equations, mode, we'll go to equations, then you have 1 coefficient of x squared. Your b there is minus 7, and press equal to, then your c is 12, then press equal to. So press equal to get your first answer. X1 is 4, press another equal to, x2 is 4, x1 is 3, x2 is 4. So that is our answer to that question. So that's singularities. Okay, that's what we do when we are asked for singularities. But going back to the question, if you are asked to find the zeros of the function, the numerator, you equate the numerator to 0, then solve it. That means x squared minus 25, equate it to 0, then solve it. That is going to give you 5 and minus 5. So I mean 5. Yes, so let's see this 5 and minus 5, sorry. Let's see this. Here we are asked to find the limit of one. It's not clear. But the limit as x tends to pi over 2, 1 minus sine x all over cos x. And we have answers here. So let's see what that would be. I prefer you use calculator here. So let's see. Let's go there. So let's say you have maybe your calculator can be in degree or radians in this case. So let me change to degree. So the question says is 1 minus sine x. Let me confirm that. 1 minus sine x all over cos x. So we'll put that fraction. 1 minus sine x. So sine alpha x, close the bracket, then common that, then cos alpha x, and close the bracket. Okay, so this is what I will press, calc. Now remember, the question says the limit tends to pi over 2. Now pi over 2 is in degree is 90 degrees. So my calculator is in degree. So what I'm going to do is I'm going to look for a number that is very, very close to 90, because substituting 90 may not work. It may give us an indeterminate answer. So we are going to use, let's say, 89.999999. Sorry. Did you see that? So what does it tend to? 0, approximately 0. So the answer to that question is 0. So we'll go back to our question, and the answer is 0, which is B. Now that leads us to the next question. Here we are asked to differentiate if y is equal to 2x squared over 3x, then dy dx is something we can solve ordinarily. 2x cubed all over 3x is something we can solve ordinarily. So let's do that quickly. So we have 2x cubed all over 3x. First of all, x here can cancel this to give us 2. So we have 2x squared over 3. So by differentiating this now, 2 multiplies 2 over 3. We get 2 over 3 times 2. Then x will be raised to power 1. Okay, that's your x now will be raised to power 1. So 2 over 3 times 2 will give us 4 over 3. So the answer is 4 over 3x, or you say 4x over 3. I think that's very straightforward. Or it's also something that we can use our calculators to do. Okay. Okay, that is actually 2x squared over 3x. So let's correct that. So when we say 2x squared over 3x, so x cancels x, so we are left with 2x over 3, which when we differentiate, you just get 2 over 3. This is so simple. This is so simple. Okay, so let's see our next question here. And I will be stopping here. If y equal to ln x, then the y dx is, the answer is 1 over x. Is a standard integral. That's not a problem. Then we see another one here. We asked to find the third derivative. Is that third? The cube. Is that the cube? The cube y over the x cube of x cos x. Well, you cannot use your calculator to find third derivative of a function, but I can quickly show you a shortcut. And let me do that quickly. We have, sorry. Okay, now this is what you have. Remember the question says y equal to x cos x, and we asked to find the third derivative. So this is what you do. You pick x first. Differentiate x, you get 1. Differentiate 1, you get 0. Differentiate 0, you get 0. That's the third derivative. So first derivative of x is 1. Second derivative is 0. Third derivative is 0. Then under here, you're going to have cos x, which is the first derivative of cos x is minus sin x. That's the one you write here. The second derivative of, minus sin x, differentiate minus sin x will still give us minus cos x. Then finally, differentiate minus cos x will give us sin x, because derivative of cos x is minus sin x, so it will give us sin x. So you can pair them this way, then apply your Pascal's triangle. Pascal's triangle, this is 1, 3, 3, 1. Then multiply them. X times 1 times sin x will give us x sin x. That's one of them. Then 1 times 3 times minus cos x will give us minus 3 cos x. Minus 3 cos x. The other one is 0 times 3 times minus sin x is 0. 0 times 1 times cos x is 0. So the answer to this question is x sin x minus 3 cos x. Minus 3 cos x. Okay? I'm having calls here. Okay, let's see. Oh, okay, let's stop here.